Students, today we're going to talk about an important way to calculate what makes up a compound. It's called the percent composition. To define it, we would say percent composition is simply a way of quantifying the makeup of a compound. The formula is really simple. We use the term mass percent, meaning what percent by the mass of a compound and its elements is made up of any given element. Theoretically, there are other ways to calculate percent. You could do percent by volume. You could do percent by moles or number of atoms. But mass percent is the easiest, most accessible way to quantify this. So that's the one that we're going to use. The reason this is useful for chemists is when you're studying a compound that's previously unknown, you don't know what makes it up. And we need to be able to, through mass spectrometry, be able to tell what's in there. And that'll give us a good clue as to what kinds of what kind of a molecule it is and what kinds of things it can do. So the formula is the mass of a given component divided by the mass of the entire sample. And to make it a percentage, multiply by 100. I'll show you some steps, then I'll show you a sample problem. We'll work through another problem. And then I'm going to show you another little technique dealing with empirical formulas that is related. So first, when you're asked to find percent composition from a formula, calculate the substance's molar mass first. This is something we should be pretty familiar with by now. You look up the atomic weights for each element on the periodic table, multiply by the number of atoms that you see there, and add them up. Next, divide each element's contribution to the total mass, to the molar mass, by that total. And then thirdly, multiply by 100%. Make it a percentage. The percents, if you've done it right, there's a nice built-in self-check. It should add up to 100% within rounding error, so you can accept anything from 99 to 101%. Here's an example. Let's say we're asked to calculate the mass percent of carbon, hydrogen, and oxygen in the molecule whose formula is C2H6O. Step one was to calculate molar mass. In that formula, we list the elements present, carbon, hydrogen, and oxygen. Note the subscripts within the formula. There's 2 atoms of carbon, and I know that because the subscript after carbon is a 2. 6 atoms of hydrogen. There's a subscript 6 after H. And there's an implied 1 subscript for oxygen. That means there's 1 atom of oxygen. Then I went to the periodic table, and I encourage you to pull out your periodic table as you're following along. If you find the box for carbon, you'll see 12. I like to round to the 10th place, so 12.0, hydrogen 1.0, and oxygen 16.0. Notice we multiply by the number of atoms. So 2 times 12 gives us 24. 6 times 1 gives us 6. 1 times 16 gives us 16. We have a total of 46 grams per mole. Okay, so here's the new part. Finding carbon's mass percent, we would say carbon's contribution is the line that you have for carbon when you add up all the numbers, and it's 24.0. So 24.0 divided by the total 46 equals 52%. Hydrogen, 6 divided by 46. Oxygen, 16 divided by 46. And for all of those, we multiply by 100%. So we end up with 52% carbon by mass, 13% hydrogen, 35% oxygen. And if you added up those numbers, 52 plus 13 plus 35, it should add up to about 100. This time it's spot on 100. So we've done that correctly. We've got the built-in self-check. Let's try another one. Let's say that we're asked to find the mass percent of each of the elements in NaBrO3. This is an ionic compound called sodium bromate. If you take the time to look up 1 atom of sodium, 1 atom of bromine, and 3 atoms of oxygen and add them up, you would arrive at a molar mass of 150.9 grams per mole. Now, to find the mass percent of each element, there's 1 atom of sodium times its atomic weight of 23. We'll divide that by the total, 150.9, and multiply by 100% to get 15%. For bromine, 1 atom times bromine's atomic weight on the periodic table, 79.9, divided by the molar mass of 150.9, times by 100 to get 53%. Oxygen, there are 3 atoms. So it's important to multiply the atomic weight of oxygen by 3. So 3 times 16 gives you 48, divided by 150.9, the total molar mass, times by 100, and you get 32%. Those percentages also add up to 100. So we know we're in good spot there. Okay, one more thing, last technique. This is a related thing. Let's say that we're given masses and we're asked to find the empirical formula. In this case, divide the mass of each element by the total mass and multiply by 100 to arrive at a percent. The totals, just like before, if you're finding mass percents, the sum of all the elements' mass percents should be 100. Let's take a look at this problem. A 95-gram compound containing only carbon and hydrogen is 79 grams carbon by mass. What is the empirical formula? First of all, this one's a little tricky in that they only give you a mass of 1 element. They do give you the total mass, and they do tell you that there's only 2 elements. So the little trick is to take the total mass minus the mass of the element that they did give you, the carbon, and subtract, and you'll get hydrogen's mass. So if you look at this line, hydrogen's mass would have to be 95 grams minus 79 grams. That gives us 16 grams. Next, we would do a calculation like this. Take the mass of carbon. This is carbon's overall contribution to the total mass, divided by the total, times it by 100, and you get 83%. For hydrogen, it's 16 grams, divided by the total mass, 95 grams, times that by 100, and you get 17%. And 83 plus 17% for each of the elements does indeed add up to 100. Let's do another one like this. Analysis of 63.5 grams of a compound shows that it is comprised of 35.6 grams chlorine, 23.9 grams carbon, and 4.0 grams hydrogen. We're asked to determine its empirical formula. This time we have 3 elements, and they gave us the masses of each of those, along with the total mass. So our calculation is to take the mass of the element that they gave us, divided by the total, times it by 100 to get a percent. So for chlorine, that would be 35.6 over 63.5. I invite you to follow along with your calculator. Times that by 100%, and I would suggest rounding to the nearest whole percent, 56%. For carbon, they gave us 23.9 grams. Divide that by the total, 63.5, and we get 38%. Hydrogen, 4.0 grams, divided by 63.5 grams, gives us a percent by mass for hydrogen of 6. Lastly, just to double check that we did this right, add up all the percentages, so 56 plus 38 plus 6, and that does indeed add up to 100. The homework assignment is going to walk you through a couple of problems like this. I invite you to try it out. Thank you for watching.